Welcome to our Feature Flag series part 6. I hope you enjoy. Before jumping to the Feature Flag series, let me show you some modifications I did in the MongoDB flags loader package. In the type feature flag in DB, I've added the fields ID and timestamps. As we want to use the same model in our service, it's interesting to have access to those fields. In flag schema, I've added the unique constraint for the name field. This creates a unique index for the name field in our collection. So if we try to create a flag with a name that already exists, we will get a duplicated error. The other modification was to add a transform function. In Mongoose, the transform function is used to modify the representation of a document when it's converted to JSON. When the function to JSON is invoked, it checks if the transform function is provided. If it's the case, the transform function is invoked with two arguments. Doc represents the Mongoose document being transformed. It provides access to the document's properties and methods. The return represents the transformed object that will be returned. You can modify or add properties to the ret object to shape the final transformed output. So here we are using transform to have a more readable object, changing the identifier type and removing the internal version field. I've also added a new Vitest describe block to check the model changes. As we are using the same before all and after all hooks for both test files, I did a extraction refactoring, moving these hooks to a third file named useMockedDB. Note that the useMockedDB function is using an arrow function to return the server. This is because we need to access the server in real time during the tests. If we just return the server, its value will be undefined because we are not yet running the tests. Now, we just need to call useMockedDB in each Vitest describe block. This solution works with jest as well. The test case is straightforward. We are simply creating a new flag in the database and checking if the transformation is working as expected. Let's look at the flag service project now. Although the project is inside the same repository, note that it's outside the package directory. As it is not an npm package, we don't want it managed by Lerna. Let's open the package.json file first. In the dev dependencies, there are two new packages, tsx and tsup. tsx is an acronym for TypeScript execute. It's based on esbuild, which means it's really fast, and it's an alternative to Node for running directly TypeScript and ESM. It has a watch mode, so with TSX, we don't need to transpile first and then use Node to run the project. tsup is a bundler, also based on esbuild. It supports TypeScript out of the box, and it's an alternative to Webpack and TSC. Usually, it's used to build the project before publishing it to an environment. Note that it is different from TSX. TSX runs directly a TypeScript code. It does not transpile the code to JavaScript. If you want to know more about tsup, you can follow the link that is appearing in your screen right now. But I will also leave the link in the description. In the dependencies, we are using Fastify. Fastify is a modern and efficient web framework for Node.js. It's highly flexible with a rich ecosystem of plugins. And we have the Mongoose package. Here is important to remember that if you want to use our flag model and loader package in this service, the flag service is obliged to have Mongoose as a dependency. In our last video, we have declared Mongoose as a peer dependency for the MongoDB loader package. So the package expects this from its host application. It will use the connection created by flag service. Moreover, the version must be greater or equals to 7.2.1. We are also using our flag package. The TypeScript config file is basically the same we have been using. However, we don't need the declaration data types. The MongoDB directory contains two files, a Docker Compose file and a shell script. The Compose file is the MongoDB service definition, so we can run it as a Docker container. It's a basic configuration. If you want to know more about this setup and more options to run MongoDB as a Docker container, watch the video in the link that's showing on your screen right now. I will also leave this link in the description below. Open a Git bash terminal and run Docker Compose app with the option detach. After the container has been started, you can run the shell script to create the flags database and its user. All these steps are in this project's README file. Now let's look inside the source directory. For the purpose of this series, we are implementing a functional but simple REST service to manage our flags. This way, we are not considering important features as authentication and logging. The goal is to use our feature flag solution to show you how to create a TypeScript REST API using Fastify. In future videos, we will explore more about Fastify features. And if you are liking this video or the series so far, don't forget to give it a thumbs up and share it with your fellows. Let's look inside the connect to DB function. The connection to MongoDB is straightforward. I'm using the connection string directly here, but before we release this in production, we would need to consider security aspects and probably get this info from a vault or at least protect environment variables. Now, let's look the build server function. I'm using the default logging feature from Fastify. The health check endpoint is interesting when deploying the service to a containerized environment. These environments usually check if the service is up during the deployment and if it is still up from time to time. The next line is to register the routes for our flag entity. Note that we are already fixating part of the path. The function register is the way to install plugins in Fastify. Plugins are similar to the Express middleware, and then we are just returning our server. The last step is start the server, listening to the specified port, in this case 3000. Here we are mapping the HTTP methods to the path and the handlers, which are implemented in the controller file. I'm using post to create a new flag, including its environments and respective user groups, and put to update the entire flag. If necessary, we could implement a patch method for partial updates. Delete to physically remove the entire flag, and then we have the gets. The first one is to return the flag by its ID. The second get is to be used by a REST loader. It returns the flags in the structure we are using to cache them in memory. The MongoDB loader is interesting and we are using it here. However, a typical application will need to read the flags from an API or service, since the flags database will not be running locally. The next and last video of this series will be about how to implement this loader as an NPM package. Now, let's talk about the controller and services. The controller contains the endpoint handlers and are responsible for handling incoming requests, processing them, and returning appropriate response. These services contain the core business logic of an application. In more complex solutions, we could also have a persistence layer to isolate database details. Each handler has two parameters: the request and the reply objects. They are similar to the request and response parameters in Express. The body field in the generics of the request object represents the type of the request body. It allows to specify the expected structure of the incoming request body. Let's check the create flag body request type. It's a synonym for the flag type, which has the structure we already knew. But the create response includes the ID and the timestamps. We ask then the service to create the flag, and if it returns null, it's because there is a duplicated key error. We are trying to create a flag with the same name of an existing one. In this case, we return the 409 HTTP status code, which means conflict. Otherwise, we return 201 and the new flag structure. Let's check the service implementation. Since our solution is very simple, we don't have much business logic here. We use our loaders model to create the flag. Note that here we don't know about requests and responses. We are just handling the input data and generating the output. For a more professional solution, we will need to think about robust validations. Then we have the service to return the structured application we will use to cache the flags in memory. The mapping we are doing here is very similar to that one we did in our last video. The other handlers are similar, but note the params field in the generics of the request object. It represents the path parameters we want to extract from the URL. Let's check the type. It's just the flag's ID in this case. We need to use the same name we have declared in our routes. This way, we are passing the ID to update, delete, or get by ID handlers. For the get all flags for caching, we are passing the environment's name. Besides body and params, Fastify has a query string and header types. Let's now test all this. For testing, instead of mocking, I'm using the real deal. For implementing the requests, I'm using a plugin named HTTP Client for WebStorm. If you are using Visual Studio, there is a plugin named REST Client that do the same thing. And you can use tools like Testfully, Postman, or Insomnia as well. The plugin works on files with the extension HTTP. In my opinion, its syntax is very clean and easy to interpret. The first line is a sequence of 3 hashes followed by a comment. This line is important when we have more than one request in the same file. It acts as a separator. Then, in the next line, we have the HTTP method, the endpoint, and optionally, the HTTP version. The next lines are for the headers fields, each one using its own line. Then, we need to skip a line and declare the request body when it's the case. The body can be declared directly here or in a file. For example, our post request to create a flag uses a JSON file. For this video, I've created a simple environment file. This is very interesting to easily change between environments like dev or staging. The environment is a JSON file. In this case, I've declared the environment dev with the variable base URL. Then, the variable will be available in our requests. We can also add scripts directly or using external JavaScript files. The client object stores the session metadata, which can be modified inside the script. Here we have a simple test example to check if the response status is the expected one. Let's run each one and check the results. The first request is to create a new feature flag. The data is in the flag1 JSON file. After running it, the request has returned 200 with the new flag, including the ID. Let me show you this in the database. For that, I'm using NoSQL Booster. But if we try to run this request again, it returns an error, since we are not allowing duplicated flag names. Now let's copy the ID and pass in the next request. This request is to update the flag. Basically, I'm adding 100 to each value. Let's run it. Okay, the object returned shows the update has worked as expected. Let's delete our flag and then create the flag again so we can check the GET requests. First, let's run the GET request to return a flag by its ID. Here, as we have a test, we can check if the test is passing. We are good, and now we can run our last request. This GET request returns an object with the structure we are using to caching our flags in memory, defined in our second video. In this request, we are retrieving the flags for the staging environment. So it's time to finish this episode. The next video will close this series. We will create a npm package to implement a REST loader using the get endpoint we have worked in this video. If you enjoyed the video, please don't forget to smash the like button and subscribe. Thanks for watching, and I see you in the next video.